All right, everybody, welcome to another episode of our Algebra 1 virtual tutor. And in this episode, we're going to look at Objective 35, which kind of continuing our departure from algebra, we're still going to be dealing with statistics. And in 35, we're going to deal with something called the z-score formula. So we're going to use the formula for something called a z-score. Now, it's important to remember that in these last few sections, we're ultimately concerned with describing statistics. So every single problem, we want to think in the context. I think it's easiest of we all take a test. There's 30 of us in the class. How do we do on our tests? Well, Box and Whisker in Objective 34 was concerned with where do each quarter of the class fall? And ultimately, we kind of drew a big box around the middle 50%. That if I could get the middle 50% above a C, that means 75% of you were above a C, and only a quarter of us failed. And it told us where everybody was, but never was I concerned with class average or your individual score. Well, in Objective 35, we're going to start to talk about our individual scores as it relates to the class average. So that's what we're going to use this idea of z-score with. All right, so we're going to start off with kind of describing what we're going through. And general statistical problems start off with a group of numbers. In our case, in our example that we're always going to keep in our head, each individual person's test average. And this is called, whoops, a little below the line there, a data set. A set of data. From this set of data, so our 30 individual numbers on our tests, we can find various measurements. Now, the most common measurement, the one that you're already responsible for, is the average, also known as the mean. And in our case for the test averages, we would take all 30 scores, add them up, and divide by 30. That is pretty much the only measurement you've ever dealt with. Now, last section, we dealt with mean, median, mode. We didn't really talk about mode. I'm sorry. We dealt with median, high, low, quartiles. Mode is kind of something that's just hanging out there. It's the number that occurs most often. But nowhere have we really talked about how spread out the data is. And what I mean by that, I'm going to pause for a second. But what I mean by that is I can have one of two things that happen. I can have a class average of an 80. Right there. So that's my mean. And X with a little bar on it is usually my mean. Now, what does that really tell you? Well, did every single kid in the class score an 80? It's possible, but very unlikely. Think about this. If all 30 kids scored an 80, you're all right here. But what happens when one kid scores 100? What has to happen in order for that average to still be 80? If just one kid was above 100, that means one kid had to score a 60 to keep this average, keep it balanced out. Now, what if two kids were here? That means two have to be here, or one kid would have to be down to a 40 to balance out the two at the 100. Now, what if three kids were up here? 1, 2, 3. Either 3 would have had to have been a 60, or I'd have to have a kid all the way down here at a 20. Let's go one more. And that in this example, it would take 4 kids at 100 to balance out one kid with a 0. That 4 kids here, 1, 2, 3, 4, could score 100. And those 4 kids, it takes 4 100s to counteract 1 0. 1, 0. And in my example, there would still be 25 of us here at an 80. And what we learn is that one extraneous value here, one extreme value, can really throw off our data. That's why in Box and Whiskers, we were concerned with the middle 50, because I got rid of both extremes. Well, now here, I'm concerned with, let's put a measurement on how spread out that data is. Are most of the people, and most of this actually isn't all that spread out, because most of the people are right around the average. But I want to put a statistical measurement that will tell me, are most of the people right around the 80, or are there, let's change this to a class average of a 50, which sounds way worse, but are there 15 kids here and 15 zeros, which would mean it's completely spread out. And I want a numeric value that will tell me that. And I want this value to be, the bigger it gets, the more spread out it is. So the smaller it is, the less spread out it is. And that value is called the standard deviation. And it measures the spread of the data. And the larger this number is, the more spread out it is. The smaller the number is, the more compact it is. All right. So here's kind of a brief summary of everything we have. The mean, always abbreviated X with a bar, and I'm not going to write these out, I'm just going to talk about them. But the mean is the average. It's all the numbers added up, divide by the total. The median doesn't get an abbreviation, but we usually just call it MED. And that's the middle value. You order them, it's the middle one. We learned that in our last objective. The mode doesn't get abbreviation at all. It's the number that occurs most often. The range is high minus low. And now we learned that standard deviation is the spread of the data. And it actually gets abbreviated like a little O's with a little tail on it there. Let's not forget that we also have interquartile range. Okay, we have formulas for the first four. Standard deviation doesn't really get a formula until really next section, and even then it's not going to be one that we're going to dwell on. What I'm concerned with, well, let's just turn the page and we'll see what we're concerned with. What we're concerned with is how your individual value relates to the data. So think about our average. I now have told you that the class average is a 50. And I've told you that the standard deviation is some number, but it somehow tells you how spread out it is. What I want to know is how your personal score relates to every single other person in the class. Are you above average? Are you below average? Now think about that. You guys do that already when you get tests back. You guys compare each other. Oh, what'd you get? What'd you get? What'd you get? What we're doing is formalizing that, and we're allowing us to figure that out without actually looking at everybody's tests. That way we aren't putting people on the spot, but you can still understand how your score relates to the whole. Okay, to do that, whoops. We're going to find the z-score of your individual test. We're going to find a statistical value that represents your score. And to do that, there is a formula. Now, for the first time really all year, this is coming straight from your SOL formula sheet, which means it's not one that we're going to require you to memorize. This is given, but What won't be given is your knowledge of where each one goes. Z-score tells you how your score represents compared to the rest of the average. X is your individual score, whereas this is the mean, and this is the standard deviation, which tells you how spread out your data is. Your job is to use this, either one, to interpret a z-score, but two, just to solve for missing values. Okay, now, what can your z-score be? It could be a positive number. Positive would mean above average, so you're better than average. It can be negative, so that means it could be below average. The bigger the positive number, the more above average you were, and the smaller the negative number, the more below average you were. So think about that. If I tell person A that their z-score was 10, and I tell person B that their z-score was 2, we can now compare test averages without actually looking at the average. Person A was obviously a lot better than person B, but both of them were above the class average. If I bring person C and say they had the z-score of -5, well then this one was below average. All right, let's look. The first thing we're going to do is we're literally just going to use z-score formula to find missing pieces. So in this case, I want to find the z-score. We're not going to interpret anything. I just want you to find the z-score. So I'm going to take my formula and plug in the data point, the mean, and the standard deviation. So 43 minus 37, divide by 3.21, and I get that this was a z-score of 1.87, and I am rounding that, which tells me that this person's score of 43 was above the average of a 37. Now, watch what happens in 2. I know the z-score. Now look at this person's z-score. It's negative. That means their score is below average. The data point I don't know, so we'll call that x minus the mean over the standard deviation. And we're going to solve this for x. Because my z-score is negative, I already know that that value has to be below average. I don't know how much. So we're going to do negative 2.47 times 5.98, add 72, and I get that x, oops, not negative 14, my bad. And I am again rounding that. Okay, well let's move it to another spot. In this case, the z-score is 1.49. I know the data point. I know the mean. I do not know the standard deviation. So this one, we're going to solve for x. And what I'm going to have to do, I'm going to have to actually multiply both sides by x and then divide by 1.59. And do that. Now I can solve it. And again, that is rounded. Well, there's only one last one I can find. It's when I am missing the mean. So data point minus mean over the standard deviation. So I'm going to multiply both sides by 5.48. And in this case, I'm going to get negative equals negative x. So I'm just going to have to realize divide by -1. and it'll become positive. So that is literally all 4 different combinations of finding missing values given a certain z-score, or given certain parts of this. Now, whoops. Let's look here. Let's start going through some of these. Now, in this one, in number 1, IQ scores have a mean of 100 and a standard deviation of 16, and Albert Einstein had an IQ of 160. So let's talk about what his z-score is. Well, the formula says z equals his individual value minus the average over the standard deviation. And I'm going to get that he had a 3.75 z-score. So a z-score of 3.75 is well above average. Okay. So if we consider usual IQ scores between -2 and 2, is his usual or unusual? And I'd say his is unusually high. Because it's greater than 2. Okay. So here we have 3 different scores. But think about it in terms of you and a friend you might have with another Algebra 1 teacher. You have 2 different teachers, and you've taken a test on, you've taken test 8. But you have 2 different teachers, so you're talking about 2 different class averages. So just because you score a 50 in one class, that 50 might actually be better because so many people did lower than somebody who scored a 70 in another class where everybody got 100. So a z-score allows us to normalize values. So what we do when we compute the z-score, let's go ahead and look at it. This person's z-score, their score of 144 minus the 128 over that standard deviation. So when I compute that, I get 0.47. Okay, number 2. This person got a 90. The average was an 86 over 18. And this was 0.22. Again, rounding these. This person scored an 18. The average was 15, and the standard deviation was 5. 0.6. So, who had the highest? Right here. This person, and now it's a stress test, so I don't know if the high score actually is good or bad, but this person had the highest relative score. They did the best compared to their peers in this group. Okay, and we can formalize that in a chart here. And what this table gives is that we have 4 different people in 4 different classes. Now, rather than talk about test scores, this was some fundraising deal, but it's the same idea. What we need to find is their actual score. So in this case, this person, Jill, the class average was a 60, and the standard deviation was 11. We can solve that to find the actual number that she raised. The next person, Kelly, different colors here. Her score minus the average over this standard deviation. Notice the standard deviation, everything's changing because it's different classes. And so we're going to use the z-score formula to find the actual number of dollars raised. You can see Tim actually did the best compared to his class, but his class was very low. So yeah, Tim did great because he was outperforming his peers in the class. But because his class average was so much lower, I might actually lean towards maybe Jill. Yeah, she didn't do as great. Her z-score wasn't as good as Tim's or Kelly's. But because her class average was so much better, maybe she actually did raise more money. So what I'm going to do, I'm going to solve each of those for x. So Jill, she actually raised $79.8. Kelly, and again, I'm going to walk you through how I'm solving this. 2.1 times 12 plus 58. Kelly actually raised $83.2. Okay. Monroe, 1.4 times 13 plus 55, 73.2. And Tim's the one I'm concerned with, because Tim did the best compared to his peers. This z-score says Tim is the best. But because this class average, we already know Kelly did better than Jill. But did Kelly do better than Tim, even though her z-score is lower? So 2.5 times 10 plus 58, and I get 83. And in fact, she did. By just a little bit, Kelly raised the most money, even though her z-score was lower. Yeah, she didn't do as good in her class because so many people did better. Her average, she was in a higher class average. But because her average was higher, she actually outperformed more people in other classes. This is what z-score tells you. And really, you want a complete picture. So we look at individual value versus the z-score. Okay, that will conclude this video. Again, we're using z-score in a couple different ways to interpret what an actual value represents and to do substitution and find various statistical values. All right, we'll see you on the next one.